Okay, so I think with that, we can go ahead and get started. Thank you so much for joining. Welcome. This is the second webinar in this series that we're doing. If you were able to join our last one, welcome back. If this is the first one that you're viewing, fantastic. We're really glad to have you. And so today's topic is going to be innovating solutions to global health challenges. So a quick introduction to myself. My name is Megan Lavery. I'm a senior project manager with Engineering World Health. I've been with EWH for several years now. I'm originally from Herndon, Virginia. That's on the east coast of the United States, not far from Washington, D.C. My background is in biomedical engineering as well as international studies. So really throughout my education, I focused a lot on designing for low resource settings and engineering across continents, all with a global health focus. So it ended up being really relevant and great context for the work that I'm doing now. Aside from that, I really enjoy traveling, rock climbing, mountain biking, all of that sort of general outdoorsiness. As far as my work with EWH goes, I am in charge of a lot of our in-person programs. So I work a lot with students who are in the field when we go to low resource settings, working in hospitals, repairing biomedical equipment. I previously worked as a biomedical technician in the United States as well. And so this is just one of the pictures of the many hospitals that I've worked in. And this is right at the beginning of the COVID pandemic, actually, and we were working on repairing UV sterilization lamps. So that's the picture that we've got here today. Obviously, you can see me looking a little bit ridiculous, all garbed up, but that gives you a little bit of background on me and sort of my experience in this area. I work really, really often with students on how to improve their designs and how to go through the design and engineering process when designing for low resource settings, specifically in healthcare. And that's what I want to talk to you about today. I also want to allow my colleague Mercy to introduce herself. She's the other expert that we have on the panel today, if you will. So go ahead, Mercy.
Yes, thank you, Megan, for the opportunity. Hello, everyone. My name is Mercy Takuwa. I'm a Ugandan from East Africa. So I happen to be a biomedical engineer from Makerere University, as well as a researcher. And I also assist in teaching, stroke lecturing, Makerere biomedical engineering students. I've also participated in a couple of engineering World Health programs as a facilitator. So currently I'm pursuing a master's degree in immunology and clinical microbiology here at Makerere University. And my interests, yes, are in design, research for all resource settings. So we do research in global health, healthcare technologies, as well as frugal innovations and diagnostic technologies. So aside from that, yeah, my hobbies, I do like traveling a lot and reading gospel literature. Thank you, Megan, for the opportunity. And yeah, looking forward to interacting with you all.
Thank you so much, Mercy. And, you know, I've had the pleasure of working with Mercy on a number of different projects through EWH and a little bit through Makerere University. And so I'm really excited that we're both going to get to talk to you about some of the work that EWH does and some of the work that Mercy does with the Makerere team and cover sort of all of that. So with that, a little bit of context about Engineering World Health. Some of you on the call might know about our organization already, but for those of you who might not, Engineering World Health is a nonprofit organization based out of the United States, but we really have a sort of global reach around the world. And our whole mission is to inspire, educate, and empower the biomedical engineering community to improve healthcare delivery around the world. And with relation to today's topic, we do that in a whole bunch of different ways. And one of those ways is by working to improve the innovation process, working to really educate the young engineer, if you will, on all sorts of different global health issues and give a little bit of global health context for engineers around the world to have a better understanding of the design challenges that they might face throughout their time as an engineer, throughout their careers, so that we can have this space for young engineers and engineers around the world to collaborate, to innovate, and better design for low resource healthcare. So with that, we do that in a few different ways with our students. The first opportunity that EWH offers is what's called our EWH Design Competition. And this is very sort of intuitively an innovation experience. So this is an opportunity where students each year can submit their design proposals or their design projects to us for review and to compete in a competition that is geared towards designing healthcare solutions for low resource settings. So we get all types of groups who will submit their projects to us each year. There are cash prizes and we give students feedback, and this is like a strict competition where students can work on their projects and continue bettering their innovations. A couple examples that we have right here. I use this example on the right all the time. I think it's a really great example of a surgical light that was developed by a team that we actually had in country with us on one of our in-person trips. So this was a surgical light that was designed to be used in Central America. With this team that was working in a hospital, they found that they weren't able to easily locate the surgical bulbs that needed to go into the overhead lights in the operating theater or in the OR. So what they did is they developed a new structure, a new operating light that used car headlights, because that was something that was easily accessible to them in country. It didn't require bulbs or replacement parts to be imported or shipped from different areas. So they designed this light that could be used and maintained and kept going in country without the need to continue maintenance from outside of the region or outside of the area. And that was a really great solution for a problem that they were facing in their hospital. So we'll get all kinds of submissions for low cost medical solutions and as part of this design competition. Similarly, we have another program that we started at the beginning of COVID to sort of not take the place, but to supplement our in-person programs when we were not able to run our in-person programs. So these are the virtual programs that we host and have been hosting since 2020. So these are experiences where students at either the university level or at the high school level, in some cases, can collaborate with other students from another country across the world. So in 2022, we'll be hosting one program at the university level for students in the United States to collaborate with other students in Lebanon on biomedical projects. And throughout this time, it's a several week long experience where students will fully virtually engage with one another, be set on international teams. So teams, in this case, teams of students in Lebanon and the United States will collaborate together on a biomedical project so that they can design a solution to a challenge that is presented to them, all focused on healthcare. And we've done this across several different countries, several different exchanges. We recently concluded a couple between Australian students and Ugandan students, as well as Australian students and Cambodian students. So that is one way that we continue this innovation process. Finally, the last way that we really see students in person and innovating is in our summer institute programs. So these are typically a 9-week-long program where we have students travel to another country and be placed in a hospital for internship. So during this internship, they'll be repairing medical equipment following a training period with us where they learn how to do certain repairs and focus on certain types of pieces of medical equipment so that they can volunteer as a biomedical technician in a hospital around a low resource country and contribute some of their time, as well as really learn about the biomedical challenges that face that hospital. So as part of that process, a lot of students come out with a much greater understanding of the different challenges that we're going to talk about in just the next couple of slides. But they're also really encouraged to come up with design concepts and ideas for new products, new solutions, and ways that after they've seen more of the challenges in certain hospitals and in certain low resource settings, they can continue to develop out different ideas that are more appropriate for those settings, and continue to improve the engineering process, the biomedical engineering process, as it relates to global health. So with that, on all of those trips and all of the different experiences that EWH has had, either doing these student programs or doing some of our in-person biomedical technician trainings, we've seen sort of these 5 common challenges that relate to medical equipment in low resource settings. Number 1 being unreliable or a lack of electricity and other infrastructure. And this is something that I think, commonly think of when considering low resource environments, but there's a whole bunch of other issues as well that contribute to what we would call a low resource setting. The second challenge to maintaining medical equipment in low resource settings is lack of user training or materials. So it's really, really common that we'll see devices that are designed for use in a high resource area and then get placed into use in lower resource areas where maybe they don't have maintenance staff or other trained personnel to repair and maintain a certain piece of equipment. So you can think of an oxygen concentrator or any sort of type of equipment, so an anesthesia machine or something along those lines, that is a more complex device that may be purchased or it may be donated for a more rural or a lower resource hospital somewhere, let's say in Eastern Africa. So in the context that we've been speaking, so in Uganda, for example, if you have a complex piece of equipment that is designed for use in the United States, that then gets donated or purchased to be used in a lower resource hospital, there can be all kinds of difficulties just due to a lack of user training. So staff may not be familiar with that device. They may not be familiar with the language that it's written in, and that can cause a lot of difficulties in maintaining that equipment. In addition to that, we end up seeing a pretty large lack of spare part supply. So that same anesthesia machine or oxygen concentrator may have very specific parts that it needs to be replaced, to be maintained. And it can be really hard to get those parts in low resource settings. So you might have to import pieces, you might have to have a specific supplier who's willing to send them to you. And in areas where maybe there's additional customs to go through, or it's just more rural and outside the cities, it can be really hard to get spare parts and components of devices to those areas. Very similarly to that, number 4, we find a lack of equipment consumables. So consumables meaning parts that we in the United States or in other high resource settings would dispose of and simply get a new one. Those things are really hard to keep in stock and keep a regular supply of in many of the settings that we work. So for example, if you are working on an electrosurgical unit, typically the pens that you use to work with those, basically the part that is going to be used in the surgery itself, the part that comes in contact with the person to do either your cuts or your cauterizations or things like that, that part is typically disposable, or part of it is typically disposable, so that it reduces the infection risk. So however, if you're working in a low resource setting and you don't have a regular supply of that part, what ends up happening is you have to reuse this part that was meant to be thrown away and have a new one come in. So obviously now you have to find a new way to sterilize it. You have to find different ways to make equipment that was meant to be single use, multi-use, and potentially multi-use for a long time. So that ends up being a really big challenge that we see commonly in the settings that we work. And then finally, we have harsh operating environments. So settings where in the United States, we have hospitals that are, they're entirely indoors. They've got air conditioning and heating. They're completely separate from the elements. In other settings, we might have like open breezeways or open hallways, areas where there's no insulation from like dust or other debris in the air. And Equipment typically just isn't designed to be used in those settings. So we see really commonly just general wear and tear that happens a lot faster on equipment that is used in low resource settings because it has to be potentially transported across outdoor hallways or outdoor breezeways, potentially across like rough, rocky terrain, potentially transported across a hospital when it's raining out, and it can just be exposed to all kinds of additional environmental factors that it was not designed to be used in. So these are 5 common challenges that we see in some of the low resource settings where EWH works, but obviously there are a whole bunch of other ones as well. So with that, I want to go ahead and play a video, and I'll have to confirm with me that you can hear it, because I know typically you can, but sometimes it gives a little bit more trouble. So this is a video that we had that students of EWH actually made. This was from a Uganda program that happened just before the pandemic. Okay, it sounds like you all are having a hard time hearing. I'm going to go ahead and keep playing it. It sounds like it's really faint, but fortunately we've got the subtitles at least. So I'm going to let it go for now, and we might be able to come back with better audio. Hey, so I apologize for the sound difficulties there. I was looking for the ability to share sound, but it was not popping up for me this time. So I will go ahead and I'll post the link to that video in our chat as well by the end of the session, so that you can watch it separately if you like. So with that, we saw a bunch of examples in this video from staff members in hospitals in Uganda and some of the challenges that they face. A lot of them relate to exactly what we just covered. So challenges with medical equipment and what it takes to maintain them, as well as the role of the biomedical engineer and that person's stake in the hospital, which is what I want to jump into a little bit next, because we have biomedical engineers as well as biomedical technicians globally who end up having very similar but also very different roles depending on the context that they are working. So when we talk about the biomedical engineer or the biomedical technician in a low resource setting, we find that a lot of these engineers not only need to have technical skills, but they also need to have creativity, patience, and familiarity with the political or social landscape of the healthcare system. Ultimately, we're finding that success in designing or maintaining medical equipment depends on an understanding of the environment in which the equipment is going to be used. So what we see is that in the case of biomedical engineers in low resource settings, these engineers are oftentimes working on equipment that was not designed for the setting in which it's being used. So with that, they don't follow the typical steps that a biomedical technician would follow to repair a device in a high resource setting. They often don't get to follow the flow chart and just see like, okay, now we replace the relay. Okay, that didn't work. Now we want to check out this other component. So this very this process that is oftentimes simpler for a biomedical engineer in a high resource setting where they can follow a set of directions and make changes becomes a lot more complex when you don't have those resources that we mentioned before, whether that be those spare parts or whether that be a set of instructions that is in your language or whether that is something like electricity. So with that, a biomedical engineer in a low resource setting ends up having to be way more creative. They need to understand not just the context of how this repair, like not just be able to read a diagram on how a repair can be done, but understand a lot more about the theory of why a device is designed a certain way, understand its ins and out a lot better, so that they can make changes and make adaptations to the device if needed, and innovate where needed to make that device more appropriate for the setting in which it is being designed in. And ultimately, I feel like what our goal should be as global engineers is to set those engineers up for more success. So if we can figure out how to design better from the get-go so that our devices are able to be maintained and able to be used more appropriately in settings globally, we're going to find a lot more success and have a really big impact on the healthcare of the communities in low resource settings. So with that, I went ahead and listed out, or I pulled this from Pro Clinical, the top 10 medical device companies of 2020. It's quite similar for 2022 as well, with a little bit of fluctuation, but 2020 is still quite accurate. So of these companies, and this is based on total revenue from medical devices, we can sort of broadly look at which companies are having the most influence on the biomedical sector in general globally. And so with this, you probably see a few names that you're familiar with, maybe Medtronic, Johnson & Johnson, GE, Philips, all of these brands that you might be quite familiar with. These are the top companies who are not only contributing to biomedical innovation and biomedical device manufacturing in their own countries, but these are the devices that end up being used globally. So I really want to keep that in mind as we sort of think about where these countries are based, or where these organizations are based, which is our next slide here. And so of these top 10 companies, we see number one, you've got Medtronic, which is which is headquartered in Ireland, but I will say they do a lot of manufacturing in the United States, followed by five companies here, which are also based in the United States. You've got number 7 and 8 here, which are based in Germany. And then finally, it's number 9 and 10 here, which are again based in the United States. So what you'll probably see here is that you have a ton of influence from the United States on medical equipment design and manufacturing, as well as some European influence. And what I really want to think about is what that manufacturing process is going to do to the overall landscape of biomedical manufacturing and biomedical design as it relates to devices being used globally. So as you can imagine, if you've got this much being manufactured in the United States, for example, you're probably going to have a lot of biomedical engineers who were also trained and raised in the United States. So with that, people are going to have a lot of inherent bias about how medical equipment is used and the settings in which it's used in. It's only intuitive that if you have an engineer who is trained in the United States, has only ever worked in US hospitals, that is going to be the context in which they understand, and that is going to be the context in which they're designing for. So it makes a lot of sense that what we see is that most medical equipment is designed for US hospitals or hospitals that operate similarly to those in the United States, which obviously is going to cause some problems if hospitals have much different structures or infrastructures, or those elements that we were talking about before with challenges getting spare parts, or all of those topics that were happening before. So it's just something that we want to pay attention to. And one of the things that we can combat a little bit in biomedical engineering training and in education is by making those future engineers who may go into these companies more educated on the global health issues that are happening worldwide rather than just in the United States, for example. So similarly, this is just repeating what I just said, but I do encourage you all to sort of take a minute and just reflect on how manufacturing location will affect the use of medical equipment globally, in addition to having engineers who are trained in like specific issues to one country. You're also going to have logistics elements of that. So if all of the equipment, for example, on our last slide, is manufactured in the US, not only is it designed for the US, but you have to export out of the US. So that is going to inherently increase costs for using that medical equipment elsewhere, because with every sale that you do now, like not only do you have to transport it to an individual, but you potentially have to go through customs, you have to transport it across potentially oceans or other areas. That is going to increase that cost. So you have a piece of equipment that is already being designed for a company or for a country that spends a lot on its healthcare. And so you can only imagine that if you have a device that is expensive to begin with, it only makes it that much more unattainable for hospitals with lower budgets around the world to be able to purchase and maintain that equipment if it also has to be exported. So all considerations there. With that, I want to talk about a couple examples of like design shortcomings that I've personally seen while working in hospitals around the world. So one of the topics that we touched on in our last webinar, if you were able to join in on that one, is what we call an equipment graveyard. And this is something that we see in hospitals, pretty much in every hospital that we work in outside of the United States. We end up at EWH seeing these medical equipment graveyards. And these are areas of just piles and piles of medical equipment, or sometimes they're outside, sometimes they're inside. This is an area within a hospital that is just used to store broken medical equipment. And the quantity in which we see this medical equipment ends up being pretty staggering. This is something that we don't have a comparison to in the United States. This is just not something that you see in US hospitals. And there's all of those reasons that we just talked about contributing to this. But basically what we see is an area where hospitals potentially have access to medical equipment. They're able to afford purchasing the medical equipment in the beginning, or they have it donated or something along those lines. But for whatever reason, or for a variety of reasons, it is not able to stay maintained in that hospital. So it's very quickly going out of service and ending up in these medical equipment graveyards. A lot of the times that simply comes down to equipment not being designed for use in the setting it's being used in. So here's an example of a student working on a wheelchair. This wheelchair, it had a pretty like decent design to begin with. It looks like it's been used for a long time, but you can see the wheels here at the bottom are bent. It looks really old and worn out, probably because it is. This was a chair that was designed to be used for X number of years in the United States, but it's been in use for so long. In this case, this was Rwanda, but it had been in use for so long that it had just taken an extreme level of wear and tear for which it was not designed. And that's something that we see sort of across the board with all of the medical equipment that we work on is general wear and tear that happens. You can see it's really dusty. In Rwanda, there's a lot of like red dust in the air that medical equipment is not designed to operate around. And so environmental factors and what we would consider in the United States like overuse ends up being a really big factor for hospitals that can't afford to regularly replace equipment. You end up using equipment well beyond a point that you would in the United States where perhaps it was designed. Another example I want to jump into here is with all of these items. This was in a hospital in Rwanda as well. This is actually one that I worked in 2016 in Musanze, Rwanda. And so all of these little kind of drone or droid looking guys are oxygen concentrators. And these are devices that supply oxygen to a patient. Typically in the United States, they are designed to be used in people's homes. So in areas where, unlike in a hospital, there's no inline oxygen supply, there's no oxygen coming out of the wall in your home. These are designed to be used in somebody's home, like next to them, and supply them oxygen if they need it inside their own home. So it's a device that's really not designed to be used for a long time. It's something that is designed to be used for a couple hours a day, potentially, usually not all day and not with multiple patients. But in the case of this hospital, this is actually in the biomedical workshop of this hospital, they have just dozens and dozens of these machines because they were using it in a clinical setting. And the reason for that is this hospital didn't have inline oxygen supplies either. It's really rare that you will see in a Rwandan hospital oxygen being piped through the walls and to patient bedsides. That just doesn't happen as often. It's a really expensive solution. So this hospital has been using oxygen concentrators for clinical patient settings instead. And that is something that is really common throughout East Africa, as well as the other regions that EWH works. And it's a perfect example of a device that was not designed to be used in a clinical setting. It was not designed to be used outdoors. It was not designed to be wheeled across rough terrain, but it is the solution that is in place. So with that, this ends up being the most commonly repaired device that our students put their hands on in country. We repair more oxygen concentrators than anything else because of the amount of wear and tear that these devices take. So things that really commonly happen, these filters here, these air filters just get full of dust super fast. There end up being clogs, things along the airlines and things inside the device that need to be fixed. We really commonly get boards or capacitors that'll burn out that need to be replaced. And there's just all kinds of environmental factors that end up with us regularly working on these devices because they weren't designed for the setting in which they're currently being used. With that, I also have one more example here before we jump over to Mercy about about the role of understanding context in biomedical design. This is not a project that EWH worked on, but it is one of the first ones that I learned in my engineering career. So these pictures are not specifically for this project, but there is a story that goes around in engineering education about a team that was designing 3D printed hands for use with kids with hand disabilities. And so this was sort of a startup that ended up having a lot of success in the United States. I'm sure many of you have seen similar pictures of 3D printed hands and other prosthetics that were being used. And this organization was really, really successful in the United States. It got a ton of use. Kids were really happy with their products. Kids were excited to show off like either a 3D printed hand that looked like this or something more bionic. And it was exciting, and everyone was quite happy with the product. So this team decided to go ahead and start a foundation side as well that had more of a humanitarian focus. And they went to Haiti, and they tried to implement this exact same project in Haiti. What they found is they did custom fittings. They dropped off the prosthetic hands with kids and implemented it in the same way that they did the United States project. Came back a couple months later, and really none of the hands had been used, and they didn't understand why that was, because it had so much success in the United States. Come to find out that the kids that they were designing for in Haiti just really didn't like the color. They didn't like having this big blue hand that really stood out. They didn't like going to school and having people stare at their hand and say, "What is that? Like, what's that big blue thing on your arm?" Whereas younger kids in the United States got a lot of positive attention for it. They were proud to show it off, and that was just a really big cultural context that ended up to their product failing in one region because they didn't understand some of the environmental or other cultural contributing factors that end up being really, really important to the success or failure of a design. They found later that when they printed the hands in like more subtle colors, more skin colors, that had greater success, but because it was still something that stood out, kids ended up being less likely to use their product at all because they would rather lose some of that functionality in their hand than attract additional attention to their disability. So I really want to emphasize the importance of understanding environmental and social context in biomedical design as well. And really one of the only ways that you can achieve that is by being familiar with your environment or designing for an environment that you are that you have been raised in. So that is a little bit of a downer, but one that I think resonates well and helps people really understand some of the challenges that you can face in global engineering, especially when engineering for environments which are not your own. But with that, I also want to jump into some positive examples of innovation and allow Mercy to talk about some of the work that they're doing at Makerere. So with that, Mercy, do you want to go ahead and jump in?
Sure. Yes. Thank you, Megan. Makerere Biomedical Engineering Unit has come up with several innovations, and some of them that I will share here are the ones that stand out fully. So you can see we have the UV sterilization device. The wooden bit of it is the card, and this is the stage at which the device is right now. So sterilization is done using UV, and as a result, we find that there is reduced prevalence of bacterial, viral, as well as fungal pathogens. And this is because it's being done locally, like we are manufacturing it locally using a company called Badaya Technologies. So we find that we shall have the end product more cheaper, and therefore we shall have so many hospitals be able to afford such devices. So they are movable, they are very affordable, and you could easily move them between wards. And so that means that infections like nosocomial infections, like COVID-19 and several others, we shall have combated most of them. So this is one of the devices that is standing out, and currently we are at testing the device. We have its, maybe I could show you, I don't know if you could see the cursor. Yeah, but where the prototype is, yes, so the blue thing on top is the sensor. So in case someone comes into the room and they accidentally open the door when the UV device is on, so this sensor will sense the movement and it will automatically go off. So it is more like a safety mechanism. And then we've put germicidal bulbs. So these bulbs are able to kill the DNA, destroy the DNA of these pathogens, the bacteria, the virus, and currently we are testing the intensity at which the bulbs are able to kill the pathogens. So the device, we have, I think right now we have like 5 prototypes, and we want to produce more because we want to first do a survey in the different facilities and see how ready are the health workers to use this device, and can they actually take it up. Yeah, so we are going to do that survey, and we hope for good results. So many of the team members are Brian Matovu, I for one, Dr. Robert, and we have Levi. So it's really a good opportunity for us to work on, and we believe that it will improve so many lives in. So I know the EWH, some of the students have also tried to come up with such ideas. But yes, it is a good thing. And for those who have come up with similar ideas, we've helped them out. And I know it's not easy for us to just begin manufacturing locally. Like Megan has said, it's hard. Yeah, we have few manufacturing companies here in Uganda. And even those who are around to do manufacturing, they only manufacture lot products. Yeah, so it's quite a challenge. Yeah, so we are trying to pull this off, and we believe in that this very year we shall be able to have ready prototypes and products that will be used in the different hospitals. Yes, that's what I can say about the UV device. And yes, so talking about the different products we've done, innovations currently in Makerere biomedical engineering unit, they are, as I've said, there are so many, but these stand out. And we have the IPED strip. So this is for early detection of preeclampsia. And it is a strip like you see in the image, in the pictorial. So it's a strip that is urine-based, and it's able to detect preeclampsia in pregnant women. Yeah, so on the strip, you can see a small dot on the down. It's where a drop of urine is placed. And the bars that you see in the middle, the bar that is standing out well is a control. And then, as you can see, the concentrations are different on that strip. If you see clearly, they marked these concentrations differently. So we're trying to test and see at what concentration do we get a positive result. Yeah, so this is also a project under testing phase, and there is even a IP that has been obtained already. So it has advanced to its final stages, and we want to begin the manufacturing. Yes, so still the people here, we have international collaborators that have helped out with getting the resources, and as well as team members from Makerere University. So it's also a good project, and we believe that if preeclampsia is detected early, then there is no reason for mothers dying in after delivery or before delivery, and as well as babies will be saved. So it is something that has won some good funding so far, and we believe products of this strip will come out, and they will be sold out even globally. Yes, we could move to the next slide. So talking about the vaccine carrier, this is my project where I'm the team lead. So we were modifying the current vaccine carrier. I couldn't have a pictorial showing the current vaccine carrier, but if you have had a look at them, they do not have temperature monitors. So that means that they've been designed for settings where health workers have to only go to vaccinate and then for a short time, and then take back the vaccines into the refrigerators. But then in our low resource settings like Uganda here, we have sessions where we call them mass vaccination sessions. And here health workers move long distances to go to vaccinate people, you know. So it really takes a lot of time for them to reach there. But then remember, vaccines are supposed to be kept within temperature ranges of 2 to 8. So below, above that, you find that they are no longer viable. So that their viability is compromised. Yeah. But then here in Uganda, you find that even after a long distance, no one is monitoring the temperatures for these vaccines. So that means people are receiving vaccines that are input, like they are not going to perform the intended use. Yeah, so they are no longer potent. And that is what is happening. So if we get a vaccine carrier with a temperature monitor, if you can see the pictorial, so this temperature monitor has a sensor that runs through to detect in case these temperatures run out of range, there will be an alarm. And this alarm will inform the user that, you know what, you better change the ice packs or do something to the vaccines. Otherwise, they are running out of the normal range and you are going to vaccinate impotent vaccines. So it is more of a safety mechanism to ensure that populations receive viable and potent vaccines. And also it reduces vaccine wastage because some of these vaccine vials have labels. Yeah. So in case the label turns a certain color, you're supposed to discard, and health workers do that all the time. So you find that so many vaccines are being wasted. Yeah. So which is not a good thing. It also saves the government a lot of money if we get to monitor the temperatures under which these vaccines are being transported and taken control of. Yes, so it is also a good idea that is being rolled out, and I think some of them need a little bit of funding, but we are trying our best to get to the final stages of testing the prototypes and then getting the final products ready to be used in the hospitals. Yes, so the team still comprises of people here in Uganda and as well as international collaborators, say from Duke University. So moving to our third product that has stood out is the Maternal PPH wrap. Yeah, call it the postpartum hemorrhage belt. So this is to offer first aid treatment, yeah, to conditions. You know, mothers tend to have this condition, and in low resource settings, it's even worse because the percentage is higher this side. So that means that mothers have to be helped in case this condition happens. Yeah, so we have devised this device that is strapped around the mother's waist. Yeah, and it has the inflatable, in the pictorial, it has the inflatable bag. So this is what provides the external compression to the uterus. Yeah, and as it does so, there is a stimulation of the myometrium contraction. Yeah, so you find that similar to what is done manually in case this incident happens, they get a skilled worker and they provide these external compressions to the mother. Meanwhile, it is more like a first aid, so as they are taken to the hospital to receive treatment. So this belt has eased work because then everyone will be able to afford it, yeah, for as long as we detect any signs of postpartum hemorrhage, then this belt comes in handy to provide the necessary first aid. And even in places where we don't have the skilled health workers or personnel to help out, so this belt will really do a great deal. And still we have members from Uganda, specifically the biomedical, Makerere Biomedical Engineering Unit. And we hope to advance it forward because right now we have the IP and we want to produce so many of these so that they can be used. and testing has already been done in a hospital. It was done in Kawempe Hospital here in Uganda. So that is already a good step. So we are only waiting for production phase. Yeah. So let me move to the other project. Okay, so we have other projects that I've not included here, like projects that help in alleviating back pain, projects that help with even better sterilization, and projects that help in providing babies with the better temperatures, so they help in solving hypothermia in babies. So there are so many, but then those are the ones that stand out, meaning that they are either at testing stage or they are going to be in the production phase. So some of those and many others, I think they will be shared with you and you will have a look at them. Yes, thank you very much.
Excellent. And with that, we're coming up on time for our webinar. So I wanted to open it up for questions. You can feel free to raise your hand or just go ahead and jump in the chat. And Mercy and I will both be here to answer questions for the next few minutes. I know I had one to go ahead and start us out, Mercy. So I guess in your opinion, what are some of the biggest challenges to improving healthcare, either related to the field that you work in or the region that you're in?
Yes, thank you, Megan. So we have several challenges, like some of them you've mentioned them, but then I think I'll try to answer the question from the perspective of an innovator. So, well, aside from challenges of limited resources, we have challenges of improper medical equipment being used, and then challenges of limited health workers. You find that here in Uganda, the doctor to patient ratio is, I think, 1 to 25,000. So that means that there are several challenges that are really hindering the quality of health being delivered to Ugandans and hospitals in general in low resource settings. But speaking from the point of view of an innovator, the main challenge will be the fact that the research, the innovations that we have come up with are no longer, I don't want to say they are no longer, but they are not being implemented. They are left, they are idle, they are not put to production, yeah? So they are not in use. And what does that mean? I mean, every time we want to improve healthcare, the things that would help us do that are not being phased out, are not being implemented. Yeah. So you find that we have challenges of limited resources, and this is due to, say, the manufacturing access. Several innovators have come up with ideas, but who can help them manufacture? There is no one. Yeah. And even if we have companies that are doing the local manufacturing, they only deal with low-tech products. So you find that sophisticated equipment or devices, you have to run somewhere abroad, yeah, to get the equipment manufactured. So it's a great hindrance. And this has really caused so many innovators to have their products just there after innovating, come up with idea, prototype, then leave the product just there without anything, without advancing it to market. Yeah. And then another challenge that I would look out for is there is limited access or platform to help or to incubate these innovations that come up, that innovators come up with. Yeah. So you find that even when you have thought, you have your good ideas, there is no platform on where you could help that could help you advance this idea to market. Yeah, it is not there. So you find that these ideas keep just dying and dying. And then also the fact that, like I mentioned, the resources are limited. So some resources may not necessarily be funding, but resources like 3D printers, yeah, we know these are very useful in the prototyping stages. Yeah, so you find that even us here in Makerere, we just got one recently, and it's a smaller version. So that means that for anything that is big, you may not have to 3D print. Yeah, so other universities don't have these 3D printers. And even incubation hubs, some of them don't have them. So you find that it's a great challenge that we don't have these available resources to really help someone try and error, because we know that the design process is you try, and then if you fail, you go back to the drawing board, come back again with a better idea. So those resources are very limited here. And I think also we face a challenge of the regulatory pathway is not really clear in low resource settings. Yeah, so you find that even the medical equipment themselves, when they come into the country, they're not regulated clearly. You find that some equipment coming in are not to the standard. Yeah, some coming in are even not suitable for our settings, so they get spoiled. Probably even the spare parts are not available. So all those things are not looked into as we get this equipment, and this, we know, it affects healthcare delivery in the long run. Yeah, as innovators, if I come up with my device, like I've been telling you, we have the IPED strip that is going to be tested and then put to market. But then the steps to follow, regulatory steps to follow. Where do I go first if I need to get approval for, maybe if I want to get IP, if I want to obtain registration or license to manufacture? All those steps are not clear. You find that few countries here have those steps laid out, but Uganda, as per se, there is no clear regulatory pathway to help us to help innovators in advancing their products from ideation to market. So I think there are so many challenges, but maybe those can work for us for now. Thank you, Megan.
Yeah, definitely. Thank you. That I know was a ton of great information on my end. So I hope it was for everyone else. The next question, we have just a minute before we'll hit that hour mark and want to sign off, but kind of ask, what are the best resources to better understand the problems in healthcare that a certain low resource community encounters? And I can touch on this a little bit. Your number one best resource is always going to be people in that community. I know that is much easier said than done, as far as like making contact with those within the community and working with healthcare providers directly. That is always going to give you the best understanding of problems that are faced. If you don't have that as a means, or if you're not sure how to go about making those connections, what I'd actually point you to are a couple of different things. Number one is the EWH BMAT library, and I'll put a link in the chat to that. But that is going to have a whole bunch of different resources that are available for biomedical technicians and other personnel within low resource settings. And so that can give you a lot of great context towards some of the challenges that people face. I would also check out things like the EWH YouTube page and our social media, because we are constantly posting different resources and things and like different webinars, and really just follow us on social media, because we're regularly posting more resources to help people better understand those different problems. It's what a major focus of our organization is. So definitely check out all the different resources that we put out on our social media, specifically YouTube, as well as that BMAT library. So, and that's now been posted in the chat. The next question we have from Gloria, and it's probably the last question that we have time for, although I'm willing to hang out for a couple minutes after our call if anyone has additional ones, says, is specific to blood pressure devices. And Mercy, I don't know if you have a specific answer to this, but Gloria says that they've been made more user-friendly and accessible. However, many prefer to go to the hospital despite having a home machine. Do you know of any plans, Mercy, to make like PPH detection more accessible or affordable?
Yes, the plan is there, and we are using materials that are locally available. So this will make it even more cheaper and more accessible. That means, so the plan is there, and once the product has been put to market, I think EWH team will be the first to know too. Yeah.
Excellent. Yeah, and I think the teams working on projects like that are just facing the same struggles that we mentioned, and trying to follow that process of getting of continuing the device development. Okay, so with that, I think that is pretty much all that we have time for. I want to give everyone a chance to sign out, and thank you so much. Kyle asked, is there a way we can get in touch with you, Mercy? I don't know if you want to give your email, but you can definitely email info@ewh.org, and we can put you in contact with the appropriate person person. If you have specific questions or inquiries, we can definitely help you answer those, and we can get you in contact with other personnel that might be able to answer your question as well.